Hello everyone, welcome to my channel. This is Karuna, resource person from the Department of ECE, teaching the course Computer Architecture and Organization. First unit contains the following topics: functional unit, basic operational concepts, bus structure, system software, performance, one human and Harvard architecture. In this topic, we will discuss about basic operational concepts. Coming to the outcome of this topic, after completion of this topic, you can explain all the operational concepts of the functional units of basic computer. Introduction. Before going to discuss about the operational concept, you should know some important points. Here, data and instructions are stored in memory, or we can say data and program are stored in memory. Program nothing but list of instructions. After storing instructions in the memory with the help of input unit, those instructions are brought from the memory into the processor for performing the operation on the data. After processing the operation, the output, or we can say output data, is transferred to either memory or register. Let us take one example for operation. Let us see the concept behind that operation. Example: add location comma R0. Here add nothing but instruction location comma R0, LOCA, that is label. Memory location is accessed with the help of label or address. Here the memory location is accessed with label LOCA. Here data present in R0 and LOCA. Add is instruction. So processor needs to perform addition operation between the data in location comma R0. Okay, so after performing the operation on the data in R0 and memory location, the output will be stored in R0. Means content of R0 will be erased, whatever stored previously. Now the result will be stored in R0. That means R0 will be rewritten by the output data. Let us see how this operation is performed with the help of functional units. We already discussed in previous video about the functional units: input device, output device, memory, processor. Okay, now in this case, let us see to perform that add operation between the data of memory location and R0, how the functional units are used to perform the operation. Here processor and memory. Processor contains arithmetic, logic unit and control unit. Apart from those two blocks, some registers are also present. So what are the registers? Instruction register, program counter, general purpose registers, memory address register, memory data register. So instruction register, which is used to store the instructional code which is currently being executed or fetched by the processor. Now coming to the program counter. Program counter stores the address of the next instruction. Apart from these two registers, general purpose registers are also present. Those are R0 to Rn-1 used to store the data. Next, these registers are related to memory or linked with the memory. Memory address register stores address of either instruction or data. Memory data register stores instructional code or data. Let us go back to the diagram how the operation is performed with the help of functional units. Initially, program counter. Program counter initialized with the starting address of the instruction. That address is transferred to memory address register. After that, control unit issue read signal to the memory. Now that address is transferred to the memory. At that address, the instruction code is present. Now processor needs to fetch instruction code as well as data. So now after transmitting the address to the memory, at that address whatever the instructional code is present, that is loaded into MDR, memory data register. Now that instructional code will be transferred to instruction register. I already told you instruction register is used to store the instructional code. Now ALU got the instructional code. Now fetching of instruction is over. Next, coming to the data. Where is our data? Data is in memory location or in R0. Processor needs to get the data from the memory location. Before going to collect the data from the memory, processor needs to send the address of the data with the help of MER register. From this MER register, address is transferred to memory. After that, control unit issue read signal to the memory. At that address, whatever the data is present, that data, or we can say whatever the data is present in location labeled by LOCA, that is placed on data bus and loaded in memory data register. Now processor got the data from the memory location. Now after that, processor, or we can say ALU, collect the another data from R0. Now ALU got the data from memory location labeled by location and from register R0. ALU perform the add operation between the data stored in location and R0. After performing the operation on that data, output will be transferred to register R0. That is the instruction format. Let us see example. Add LOCA comma R0. Let us take LOCA location 0, 0, 0, 0, 0, 0, 1. The data is 1. That memory location is assigned with some label LOCA, and another data is available in R0. So perform addition operation between these two data. You will get the output data 0, 0, 0. Answer is 3. That output data again will be stored in R0. That means after performing addition operation, output automatically stored in register R0. Let us see operational steps one by one. Usually programs and data resides in memory. Before going to perform any operation, PC program counter is initialized with starting address of the instruction. Next, the starting address is transferred to memory address register. Read signal is issued by the control unit, and then at that address the data is loaded in MDR. Next, the data, whatever the loaded data in MDR, transferred to IR. Here the data is instructional code. Now instructional code is stored in instruction register. Then decode that add instruction. Now fetching of instruction is over. Coming to fetching of data. Data may be in registers or in memory. Registers nothing but general purpose registers R0 to Rn-1. So here operands are at general purpose registers or in memory. Okay, to access data, first processor needs to send address of the data to the MAR, and then control unit sends read signal to the memory. At that address, whatever the data present, that will be loaded in MDR for performing the operation by ALU on that data. After performing the operation, the result can be stored in general purpose register or memory. To store the data in memory, first processor needs to send the address. So that's what here MAR is used. After that, whatever the processed data in the MDR, that will be transferred to the memory by issuing the write signal to the memory by the control unit. First, address is transferred to the memory, then whatever the output data is available in MDR, that will be loaded to the memory after issuing the write signal by control unit. Program counter will be automatically incremented by 1 for performing the next instruction. Let us see summary. We have discussed the example add location comma R0. This instruction performs the data in R0 and in memory. So this instruction performs add operation between the data resides in R0 and memory location. After performing the operation by the ALU, result or we can say output data is automatically transferred to R0, and also that can be transferred to memory for future reference. Let us move on to the questionnaire slide. What are the general purpose registers? List out the arithmetic operations. How the operation performed? What is the purpose of program counter? What is the content of MAR? Thank you. We will meet in next video.